Hello, everyone. My name is Dan Painter. I am the Product Training and Development Manager at Flint and Walling, and we'll be hosting today's broadcast of this web conference titled VFD Quick Start Programming. It was several years ago, back probably in around, 2014, 2013, somewhere in that area. Flint and Walling launched their own line of variable frequency drives along with control boxes and our own stainless steel submersible pump motors. So these drives have evolved considerably since the initial launch, and so today is basically I'm going to walk you through what's we call our quick start programming. I'm going to try to pull my cursor up here, and whoops, didn't mean to do that. All right, let's try that again. Or my laser pointer so that you can see it hopefully on the screen. When we look at the variable frequency drives that are offered by Flint and Walling, these are referred to as Commander Pro variable frequency drives. The drive that you see on the left, that Enclosure, is available in either a 1.5, 2, or 3 horsepower. That was our initial launch. All 3 of those horsepowers fit within the same type of enclosure, and so it didn't require any more real estate. Then maybe 2-3 years ago, we introduced this 5 horsepower drive on the right-hand side. So it's just a slightly larger enclosure than the one on the left. So again, the 1.5, 2, and 3 all fit in within one enclosure. And then the 5 horse is a slightly larger enclosure. The other thing I'd like to point out, and this is probably fundamental to a lot of you, but a variable frequency drive can drive any horsepower motor up to and including that of which it's rated. So, for example, that 1.5 drive can run a 0.5 horsepower motor, a 3/4, a 1 horse, and a 1.5. And same with the 2 and the 3. So you can run any horsepower up to what the drive is rated at. You just can't go the other direction. You can't take a 2 horsepower drive and try to operate a 3 horsepower motor. So you can't go that direction. So just, again, I'm sure that's fundamental for most of you, but I wanted to point that out here at this time. And moving on, some things that you should know before even installing these drives, and this is going to very much expedite the initial programming and installation and all that, particularly the programming. I had a thought come to my mind here just a second ago, and it left me, but it sure will come back, I'm sure. Anyway, just some things that, here it is, told you it would come back. As a product training manager at Flint and Walling, it was probably 3 years ago or so, I don't know, time goes by so fast, I decided to write a quick start guide for our Commander Pro variable frequency drives. And the reason behind that is that if you look at our installation and operating manual, and I don't care if you look at any other manufacturers of other brands, one thing that is common is they're very, very detailed and lots of pages. I think it could be 30, 40, 50 pages in an installation operating manual that goes with a drive. So that said, as a product training manager, I thought it'd be a great idea to bring out to the forefront those things that you really want to know, that you really want to check on your initial programming, so that when you leave the job site, you don't have to leave with your fingers crossed, hoping that you got the drive programmed properly. So here's some things. I got the quick start guide completed. And lo and behold, engineering and the design team decided to go ahead and build it right into the programming. And so that's what we're going to talk about today, is this initial quick start guide programming. And so some things that you would want to know, and again, some of this is going to be fundamental. I think there may be something else that could be required just a little more moxie. I'm trying to move my dashboard. I don't have the preview screen here in my home where I'm broadcasting this from like I do in my office, so I got to move that dashboard out of the way, see what kind of text I got up on the screen. Anyway, obviously this first one's kind of a no-brainer. when we program a drive, we want to let this drive know, are you going to operate a submersible pump, which, you know, very, very common, or are you going to operate an above ground pump, like, say, a centrifugal type pump? So we want to know what type of pump we're going to operate. That's a no-brainer. Then we want to know what type of motor. When it comes to the type of motor, what we're really looking for there is horsepower. What horsepower of motor is this drive going to operate? Now, when you purchase a 1.5-horse drive, that's going to leave the factory set up to operate a 1.5-horse motor. Same with the 2, 3, and the 5. But if you have a 3-horse drive and you want to operate a 2-horse motor or a 1.5-horse motor, you're going to have to tell that drive what horsepower motor it's expected to operate. And when we do that, we express that horsepower in a little different term. So it doesn't come right out and say, you know, what horsepower. It comes out and asks, what is the max motor amps? And so knowing what those max motor amps are for any given horsepower motor is going to facilitate the initial programming here. Because not all motors that this drive could be subject to running, whether it's a Pentec or a Franklin or our own, they don't necessarily all have the same max motor amps ratings. And so we want to look at that max motor amps, because that's what we're going to tell the drive what horsepower it's going to operate, what motor horsepower it's going to operate based on that max motor amps. I'm going to circle back on that here in a little bit. We also want to know if it's a single phase or a 3-phase motor. And again, just having this knowledge in our head as we go up to the drive to program it is just going to make all our programming extremely simple and easy. Like I said, some of this is a little fundamental and some of it's going to require a little more moxie. So for example, type of submersible pump. All right, so what we're looking at are the motors or type of pump, submersible or above ground. All right, so again, this is not to insult intelligence. There's some seasoned people we have out there. But if you're brand new to this, that's what we're talking about. What kind of a motor is it going to operate, a submersible or an above ground? And then when we look at the max motor amps, every motor is going to have a nameplate or a data plate on it somewhere, and it's going to give you a lot of information in regards to that motor. It's going to tell you the volts, the RPM, the hertz, the horsepower, and on there somewhere is going to be max amps. And that's the number that we're looking at. So, you know, I'm not looking to plug in 1.5 horsepower per se. I'm looking at what is the max amps for that 1.5 horsepower motor. That's what I'm going to plug in there. So hopefully we've got that kind of drilled home there. And again, single phase or 3-phase. So for example, if we choose a submersible pump, there's a couple other things that we ought to know about. And by and large, first and foremost, we need to know if the pump end is matched up with the motor horsepower. If you're going to take this drive out and put it on the off-the-shelf Flint & Walling pump or somebody else's brand of pump, and that, you know, it's an off-the-shelf pump, meaning you buy a 1.5-horse pump and you get a 1.5-horse pump and motor. If those are matched, then we're going to set this, we're going to set the max frequency at 60 hertz if that pump and motor is matched. Any above ground pump should we have selected, you know, a centrifugal pump. It'll always run at 60 hertz. However, there is one other occasion if the pump and the motor are not matched that we're going to run it at 80 hertz. And let me just pause here for just a second and give a little explanation what I'm talking about. Back in the day, and this is many, many years ago, I don't know, 15, 20 years ago, quite frankly, Flint & Walling was the first pump OEM to go to market with I would almost consider it a water system in a box. We would put in one shipping box. We would put a variable frequency drive. We'd put a motor in there. We'd put a pump end in there, and we'd put a switch to turn it all on and off. And early on, we used to put a little pressure tank in that box as well. But those were called package systems. Today, we don't package pressure tanks with these drives, these packages, but we do package pump end, motors, drives, and the switching device. Now, on our package systems, Flint and Walling has always, I'm going especially, has always mismatched their pump end to the motor. So, for example, if you bought a 1.5 horse package system, not just the drive only, but a package system, in that package, you would have got a 1.5 horse motor with a 3/4 horse pump end. We would have put a 1 horsepower motor with a 2 horse pump end. We would have put a 1.5 horse motor with a 3 horse pump end, and then we would spin it faster, i.e. 80 hertz. And the thing that we were able to accomplish with that is it gave us a very nice broad performance curve. If you look at the curves that are in the catalogs, it's, you know, very nice broad performance curve there. So basically, when it comes up and it asks you about what frequency you're going to run you want your drive to run at, it's going to be 60 hertz if the pump end is matched with the motor. It's going to be 60 hertz, and if it's an above ground pump, it's going to be 60 hertz. And the only time we would run it at 80 hertz is if we mismatched the pump end to the motor. And the only time that Flint Walling ever did that was if you bought the package system. So hopefully I explained that clear enough that you understand what I'm talking about there. And I'll probably circle back on this as we actually look at the programming itself. But here's a couple examples. Over here on the left-hand side, those are all matched pump and motors, all horsepower to horsepower, so they're going to always run at 60 hertz. But on this mismatched side, you know, like I mentioned early on, we used to put a 3/4 horse pump in with a 1.5 horse motor, a 1 horse pump in with a 2, and a 1.5 horse with a 3 horse motor. So the pump end was rated at about half the horsepower of the motor, and we would spin that rascal at 80 hertz and get our performance out of it that way. So a couple things about the drive too is that before we go into the programming, is your drive equipped with a transducer or a pressure switch? Now, talk about this for just a second too. Back in 2014, when we launched this drive, we launched it at the NGWA show. I think it probably was in Vegas at the time, or Nashville, I can't remember. But when we went to the show, we were showing this F&W drive here, and we had brought a lot of contractors in for input. Okay, so you all have been selling various brands of drives out there. If you were part of the design team, what would you like to see improved upon? And we took all that as gospel. And so we introduced our drive initially with this pressure switch that you see down here at the bottom. And I guess the primary reason for that is that that's the same type of switch that we had used in previous years prior to our own design and development with the Franklin sub-drive. And quite frankly, I don't know that, you know, if somebody said, well, you know, were they problematic? I'd have to answer no, they weren't. I mean, they seem to work just fine in these type of applications. I have had some contractors, on the other hand, that don't particularly like them, because at that show, when we were introducing this drive and they saw what the programming looked like and how we display the various faults, there's no code you have to read. There's no flashing lights you have to count. It just comes right out and tells you, hey, you've got a short circuit or some type of fault. It'll display it in English. And the contractors really kind of liked what we had done with this drive. And I know that one particular contractor looked at me and said, now, what type of transducer are you using? And I looked at him and I said, well, we're not using a transducer. We're using a pressure switch. I don't like those. And I mean, I really don't like those. So tell you what, son, if you can ever make that drive operate on a pressure transducer, come on back, talk to me. We may have something to talk about. He didn't like the switch. So we ship them both ways. We come back from that show, we set the drive up, and within a very short period of time with some software changes, we now have a drive that'll operate either off the pressure switch at the bottom or the pressure transducer at the top. And I'm going to just share an opinion with you, and it's just my opinion. I wouldn't expect Flint and Walling to endorse this, but in my opinion, this pressure switch is dying a slow death. It really is, because this pressure transducer is much more popular. And like a guy told me, he said, you know, I don't like this pressure switch for a couple of reasons. Now, they're not life and death, but I'm going to explain to you what those reasons are here shortly. Like I said, I don't know that I have a preview slide over here, but to know what slide's necessarily coming up next, but let me just check. Okay. All right. Nope. I'm going to go back to this previous slide here. Just a couple of things here before we go too much further. This is a Nema 3R enclosure, and that's the same enclosure that we use on all of our drive family. Every horsepower is going to have a Nema 3R, meaning that it is designed and for indoor and or outdoor applications. I get a lot of people asking me, well, why not go Nema 4? Well, we could have, but we're going to drive the price way up. When Nema 3R is rated for outdoor, that's, we looked at that as satisfactory because it'll protect that the insides against the ingress of rain, sleet, water, snow, and ice. And so, quite frankly, I don't know what else falls from the sky that we would want to protect it from. But the difference between a Nema 3R and a Nema 4 is a Nema 4 could, in fact, take a direct water spray, like, say, a fire hose. But, odds are that's probably not ever going to happen, so we opted to go to the Nema 3R route. When looking at the drive and programming it, basically you walk up to the drive, you've got your display right here in the front, and on that display are 6 buttons or 6 little tabs. So I think it would behoove us to just become familiar with what those tabs are. And so they're coming up on your screen now. So moving from left to right, we've got it up, and then we've got a down. That allows you to do your scrolling up or down. You've got an edit button, an enter button, an escape, and a stop start. So just those 6 buttons there. So if you ever want to make a change in the drive programming, you want to change the factory setting of 50 psi. You want to run it up to 60 or 65. If you ever want to make that change, one of those 6 buttons is going to allow you to make a change. And I think most of you, if you were look at those buttons, it's obviously the edit. The edit button will allow you to make a change. And so if you want to, just for example, you want to change that pressure setting from a 50 psi set point up to 60 or 65, you would hit edit, and it's going to ask you to make your change. And then what you're going to do is you're going to use your up and down buttons, and you're going to scroll up or down to achieve, in this case, we're going to run it probably up to 60 or 65 psi. If it happens to be frequency, it's the same thing. You're moving the frequency up and down or anything else. It's just it's going to allow you to select what change you want to make, those up and down buttons. Once you've made that selection, then obviously the last button you're going to hit is the enter button, and that's going to save it. So edit, and the beautiful thing I think about this F&W drive is this keystroke pattern never, ever changes. It's edit to make a change, up and down select a change, enter to save a change. The escape button, all that does is take you from wherever you're at back to the home screen again, and it's not going to save anything. So if you're midway through changing some programming, you get a phone call or you get distracted or you forget, where you're at with this, maybe it's just best to just run back through it again. So that escape button, all that's doing is going to take you right back out to your home screen, and that is the home screen that's being displayed right down there at the bottom. And then the stop start button, I shouldn't have to give too much explanation on that. It's pretty self-explanatory right on the button itself, but it's a simple manual stop and start of the drive. So those are the 6 buttons. Each one has some functionality to it. So let's go ahead and look at the drive itself as far as this quick start programming goes. So the moment that you power the drive up, the very moment that you power the drive up, or the drive sees power, this is what you're going to see in the display. And as I mentioned earlier on, the design team took my little quick start guide and they built it right into this programming. So let's walk through this kind of in a virtual way. There's a no-brainer for you, right? Press enter to begin. So that's what we're going to do. We're going to press enter to begin. And once you do that, it's going to ask you about these motor types. Again, we need to make sure the drive is either, if it's programmed for a 1.5 horse and you're using a 1.5 horse, we're going to walk through this just to make sure that the folks back at F&W programmed it up properly. If you're using it for something, you bought the drive separately and you're putting it out on some other pump, we're going to walk through this. So again, what you'll then do is you'll use your up and down buttons. And by using your up and down buttons, you'll be able to scroll from above ground to submersible, but, above ground to submersible. So we'll make a selection here. So we're going to go ahead and select submersible. We want to save submersible. So the next thing we do is we hit the enter button. Pretty easy so far. After we hit the enter button, it's going to ask us to select motor type. And once again, we can use our up and down scroll to go from 3-phase to 3-wire single phase. And very shortly, I'm talking about days, not months, there'll be a third option up there. And we're very, very excited about this third option. So you'll have the choice between the 3-phase, the 3-wire single phase, and the third option is going to be a 2-wire single phase. And it's just, again, we're right on the threshold of this, and it's more in the term of days, not months. But anyway, we'll just go ahead and, I guess, for purpose of display, we'll go ahead and we'll select the 3-phase motor. We hit enter. We know what that does. That saves it. And then, so where are we at? We're 2 menus in. So we go to the third menu. Here's where it's going to ask you to set the max motor current or the max motor amps. And again, this is how we're going to display what horsepower motor that this drive is being expected to operate. So when I look at this one right now on your screen, it says 6.0 as the max motor amps. That's probably in line with maybe a 1.5 horse, 3-phase motor. If it were a 2 horsepower, it'd be perhaps 8.2 or 8.3, and a 3 horsepower would be 10.3, 10.2. But there's where you would, if you wanted to change the horsepower on this, you would hit the edit button. And then using your up and down, if you're going from 1.5 horse to 2, so you need to raise that max amps from 6 to say 8.2 or whatever the rating is on that motor, you'll use your up button to get to that point and then hit the enter to save it. Voila, you just changed the horsepower of the motor that drive is going to be expected to operate. So again, this is real easy programming up front here. Number 4 is the max frequency. And I was trying to explain that earlier on, that the only time we're going to run 80 hertz, the only time, is if it's a submersible pump, A, and B, the motor and the pump end are mismatched. Everything else will run at 60 hertz. But if you selected submersible like we did when we started into this programming, it's going to ask us to make this determination. Do we want to run that submersible at 60 hertz or do we want to run it at 80 hertz? If we had selected above ground pump, we get to this menu number 4. That's it. You can't change it. You would not be able to change that 60 hertz, because never ever would we want to run a above ground pump at a rating greater than 60 hertz. And then the last of the menus, the very last one, it's going to ask you to set control. And again, you're going to use your up and down buttons, and you're going to you can scroll between transducer and switch, transducer and switch. I mentioned early on that this drive can operate off of either one. And I also mentioned that the switch is, I think, probably, I don't know if we'll even be selling it 1.5 years from now. It's just, I think the popularity of it's going down. Everybody's liking the transducer. Had I selected switch here, if I'd have used my up and down buttons and I'd have selected switch, the next thing that's going to pop up on my screen is it's going to say press start to continue. And I'm done. I'm done with the programming. But since so many of these are going out with a transducer, you're going to select transducer when we get to this last menu of the quick start where it says set control. You're going to select transducer. Now, when you do that, and this shouldn't be, no one should get real apprehensive about this, but when you select transducer, there's going to be 3 sub-menus that are going to pop up and prompt you for an answer, such as number 1. it's going to say, well, what's the range of the pressure transducer that you've got on this system? Well, I'll answer that. It's 100 psi. That's what we ship out with the packages. That's what we ship out with the drives, and that's a standard transducer I think the industry uses. That we all have larger pressure range transducers. We go up to 300, I think, 300 psi, but that's the exception to the rule. 95 or more percent of these that go out, more than that, 98% of them are going to go out with a 100-pound transducer. So all you do is you look at that, it's 100 pounds is already in there. You go, yep, that's what it is. You hit your enter button, and then your next submenu pops up, and this is where you set your pressure point. It's going to be factory default at 50 psi, but if you want to change that, you use your up and down buttons, and you can run it up or you can run it down. How far can you run it up? Well, you can. The programming in a drive is going to allow you to run your pressure set point up to within 5 psi of the range of the transducer. So theoretically, you could run this all the way up to 95 psi. I'm not sure what the application would be that would warrant that, but that's the range that you have. And this is one of the reasons why the guy said, I don't like that pressure switch for a couple of reasons. One is if you want to set your pressure set point on a drive that has the pressure switch, then you got to pop that rubber boot off. And I'm not going to go back to the previous slide, but there was a rubber boot on the top of that pressure switch. You pop that rubber boot off. And then after you've got the boot off, there's a black tower with a rubber grommet in the top of it. You pop that rubber grommet out. You take a hex-headed screwdriver, you put it down into that black tower, and you turn this hex-headed nut clockwise if you want to increase the pressure, counterclockwise if you want to decrease the pressure. It's very much like a conventional pressure switch. You're probably going to have to look at a gauge as you're turning this. And I kind of got to the point where I thought about a quarter turn was a 3-pound change, either up or down. But the guy says, this is so much easier because all I have to do is just scroll my pressure up or down where I want it. I like this. And that's why one of the reasons why he liked this over a pressure switch. Like I said, it wasn't that the pressure switch had mechanical flaws. It's an ease of installation. And then the third submenu that's going to pop up, it's going to ask you to set your drawdown. It's going to come out at a factory default of 5 psi. Basically what we're saying there when we talk about drawdown is how far below that set point pressure that you've got do you want the system pressure to drop before this system comes on, before the drive powers up and brings water. Well, that drawdown is 5 psi. Most people cannot determine a 5 psi drop in pressure. They can determine a 20 psi drop in pressure, but a 5, not so much. But you do have, the choices. I think if you wanted to change that for whatever reason, your choices are from 2 to 15 psi. But a 5 psi is typical. It's a factory setting, and so many times once you set the transducer, you look at the 100 psi, you go, yep, enter it. You look at the 50 psi, you either say yes or no there. If yes, 50 is all right, enter it. If you're going to change it, and then enter it. And then you get to the drawdown, 5 psi is okay, enter it. And so, again, it's taken me a lot longer to explain this than it would be if you were out there actually doing this on a job. So once you get to that third menu, that third submenu, then just like the pressure switch, you're done with the programming. It's going to say press start to continue. And once you press that start button, the next display that's going to come up is going to say saving memory to saving memories. It's going to save the changes that you make, and then you'll come back to your home screen. And this is what your home screen looks like. And this is the other reason the contractors like a transducer over a pressure switch, because had I selected a switch, I'd have got done a little earlier because it doesn't come with those 3 sub-menus that the transducer comes with. But had I selected a switch and I come back to my home screen on a switch, all that would have been there is it would say motor in standby, 0 amps, 0 hertz, no time, not ever, never, never, never is pressure ever displayed on the display screen. And so many times these contractors are out and they're selling these things on the premise of constant pressure. I get it that homeowners don't understand hertz. they may or may not understand amps, but they all sure understand PSI. They've been putting it in their bike tires since they were kids. And so to be able to display pressure out there in real time, all the time, they like that. And so that was the second reason why they preferred the transducer over the switch. But again, this is and as that pump drive powers up and it powers that pump motor up, you're going to see these being displayed here in real time. All three, pressure, amps, and hertz. But again, it took me 30 minutes, darn near, 30 minutes to explain this all to you. But if you know those few things up front, as I mentioned, just, again, some of it is not to insult anybody's intelligence, but some of it is just so no-brainer. Is it a submersible pump? Yes. Does it have a 3-wire motor, a 3-phase motor, or a 2-wire motor? What's the horsepower? What's the max amps? So what are you going to run it at, 60 hertz or 80 hertz? And then is it running off a transducer or a switch? I've done this myself. I confidently say that if you do know those things up front, and maybe not the first time, but the second time you program a drive, that initial quick start programming ought to be something inside 2 minutes or less. All right. Now, I'm going to pull that back off the screen there, just a hair. Now, let me tell you this. Once you've been through that quick start guide and you hit this hit start to continue, and it says it's saving everything to memory, and it comes up and it displays this home screen. Once you've got here, that quick start guide is now gone. It's not in the programming anymore. And again, it's up front just so we get those 4 or 5 parameters dialed in before we leave the job site. And really where we're at now is where we were at initially when we launched this thing. And before the design team decided to put that little quick start guide right in the front of it. So let me just walk you through this. This, again, is pretty simple stuff here. So you've programmed the drive, and you're out to service it or whatever. I mean, you come back out to the drive. You can come up and you can press any button on there you want, and you're going nowhere. And that's by design. Little kids like to come up, they like to press buttons, they like to punch them. But if they see that nothing's happening because of it, they get bored, they go find something else. So it's kind of got a little child-proof programming initializer here. So you like I said, you can go up and press those buttons like you're playing a piano keyboard. You're not going to screw anything up, and you're not going anywhere. You're just going to stay right here. If you hit the stop button, you might turn the red light on, but short of that, I mean, nothing's going on here. So in order to get into the drive from now on, after you've initially programmed it, and I've got my circle up here wrong, folks. Last time I did this, I noticed it, and I never changed it. But it says you should hold the edit and enter buttons. That circle needs to move. That red circle needs to move to the left 1 tab. But you're going to hold the edit and the enter buttons simultaneously. And this is going to allow you to get back into the programming. And so when you hold those edit and enter buttons down, it'll say entering setup. And when you see that, you can release those buttons, and there they are, the edit and enter buttons. I'm going to move this dashboard now back over to the other side here. And so here's where you're going to come into. The first, so you hit the edit and enter buttons, you enter the programming, and your menus are going to come up this way. You're going to have select control. That's the first one. So that's quick start guide. It went away, but not really. It's coming back to us, not necessarily in the same sequence. So for example, hitting the edit and enter buttons, once I go back into the program, and from now on, the first menu item there is the select control, and that's your choice between transducer and switch. Menu number 2 is going to be your max amps, which is going to tell the drive what horsepower. And then number 3 is your frequency, what frequency you're going to run that at. And by the way, when you get to number 4, menu number 4, you can password protect this drive if you so desire. And I'm going to guess that most drives are on the market that I'm sure their password can be password protected. And I get asked that all the time. The question I get asked more than anything else is, hey, painter, What happens if I get called out on a job somebody else sold and they're not in business anymore or whatever, and they put a password on that drive? Now what do I do? Well, if you want to set a passcode, you're going to hit the edit button, and it's going to say set passcode, and you're going to turn it on. Okay, so now you got the passcode turned on. It's going to ask you for 5-digit passcode number. You're going to use your up and down buttons to select your first digit, hit enter. It bumps you over to the second digit. Use your up and down button, select the second digit, hit enter. You do that 5 times, and once you hit enter, now you've got it password protected. So now, if you come back to the drive, you hit the edit and enter button before you go anywhere. It's going to ask you for that password. And so the guy asked me, he said, well, I'm sure y'all have a back door, don't you? And I kind of tongue-in-cheek said, well, sure, we got a back door. And I'll even share it with you. Apple doesn't want to do that with their iPhones, but I'll share our back door with you so you can get inside any drive you want. And they go, well, great. What is that? I said, it's simple, man. It's really easy to remember. Well, what is it? I said, it's Flint and Walling zip code. They go, what? I said, it's Flint and Walling zip code number. Well, how in the hell am I going to remember that? On the side of the drive, there is a label. It's got the model number on it. It's got Flint and Walling on it. It's got our address on it. It's got our zip code on it. So it's actually right there on the side of the drive. Be careful who all you share that with, but that's the back door to get into a Flint and Walling drive is just plug in that 46755 zip code and voila, you're in. So, but there are other menus beyond that. I only today wanted to go through the quick start programming, but some of the other menus that you're going to have is you're going to have your underload protection, which is going to, typically comes into play during run drives or deadheading situations. We've got standby sensitivity. We've got a broken pipe mode down there. I'll tell you a quick little story on this broken pipe mode. Back years ago, we were in field test, and we had a distributor up here in northern Indiana that had an outside salesman that was going to help us with our field test of these drives, and so we upgraded his home submersible to include a variable frequency drive. And the only thing we asked is to be able to come in periodically to just kind of do a check and balance and monitor it and see how things are going. And, it got to be, February of the year. And all of a sudden the guys started calling. He said, man, this drive's kicking out on broken pipe every day. There's some days I think it kicked out twice. I said, well, what do you mean? He said, no. I said, everything shuts down. I go down to the drive. It says broken pipe. What do you do? He said, well, I hit the stop start button. It comes right back on and it runs again. But hell, a few hours later, it's going to kick out, and it's been doing it. He says, quite frankly, it's becoming a nuisance, a pain in the butt. I'm leaving for a road trip, and I don't even know if my wife would know what to do if the thing kicks out on broken pipe. I'm not sure she'd know how to get water. And I said to him, I said, well, dude, fix your leak. He goes, I don't have a leak. I don't have any broken pipes. I don't even have so much as a drip. You got to be kidding. He said, no. And he said, but that's what it's saying. It's saying broken pipe. So we got to talking. As I mentioned, this was February. And we got to talking about this guy's, we evolved to his water system. So let's go to the pump. Yeah. Well, talk to me about the pump. What size pump is it? Well, he says, I'm using it for geothermal. You what? I'm using it for geothermal. I said, dude, it's February in northern Indiana right now. How cold? I don't even think I was in Indiana at the time. I said, how cold is it back there? He goes, it's 9 below zero, and it's been that way all week. I said, that pump ever shut off? He goes, well, hell no. It's running. It's running 24/7, just trying to keep up. Well, guess what? The pump never shut off. Well, after a timer, this is simple. This broken pipe mode's nothing more than a timer, and you can set it from, 4 hours, 8 hours, 24 hours, and what happened is the pump never built up pressure, never shut off, and the drive did what it was supposed to do. It said, dude, you've been running, you've not built up pressure, you've not shut off, there must be a leak somewhere. Boom, it kicked out on broken pipe mode. And the drive did exactly what it was supposed to do. But again, this was a nuisance because that pump was not shutting off when we were at sub-zero, and wind chill probably took it down to another 20, 30 degrees below zero. So all we did, folks, is we went into the broken pipe mode and we turned it off. And that problem went away. So there are times you're going to have to come back, maybe hit the edit enter button. But we turned it off. This is an exception to the rule. I told him when spring comes, you might want to put it back on because it's good insurance to have, but just to keep that from nuisance tripping. Then there's advanced features. So there's you get down to menu 9, and that takes you back to the factory default. So at a later date and another web conference topic, I'm going to go into some of the advanced programming and settings as we try to get more topics coming up. The other thing I'd tell you about is if you use the up and down buttons, you hold those simultaneously, just like you did the edit and enter buttons to get into the programming. If you walk up to our drive and you press the up and down buttons and you hold them down just for a few seconds, you're going to enter into our fault log. And what you'll have now are the various faults that can be displayed, and this is how we display them. So for example, if you've got an underload, it's going to come out and tell you, dry well. No flashing lights, no codes, no symbols, plain English, dry well. Here's one that says deadhead. Locked rotor. That one went behind my dashboard. I'm not sure what that one said. Under voltage. There's more. Short circuit. Here's hey, if there's a broken wire, our drive is not only going to tell you that you got a broken wire, it's going to tell you what leg is open. So it sends 3 pings down that pump cable and decides which ping didn't come back. So it can be displayed black leg open, yellow leg open, red leg open. But it's very nice. Overheat. I think that's broken pipe. That's behind my dashboard. External trip. External trip can occur. And by the way, if you ever get one of these, it's got nothing to do with the drive. It's something that is wired to the drive that is external of the drive. We've got applications in livestock where if it's poultry, turkeys, hogs, and they're out of water, they want to know, and they want to know now. So they may have lights or a horn or any number of things can be wired into these drives. Liquid level controls, lightning arresters. So there's any number of external devices or components that can be wired into the drive. And if one of those goes into goes awry, that's the kind of a message you're going to get. It's going to say it's an external trip. And so this drive will hold 20 faults, so it'll store up to 20, and they're all in numerical order, as you can see here. Once all 20 are filled up, that may or may not ever happen, but once all 20 are filled up, you get nuisance tripping going on, like the guy with the broken pipe. He was getting 1 or 2 a day. So, but once they fill up, then when the new one comes in, it takes the number 1 spot. Everybody else moves down 1, and number 20 goes off the screen and goes away. So it only stores the last 20 faults. But another cool thing is they all will come with a timestamp. And that timestamp's going to read in hours or days, hours, and minutes. So, for example, I could look at this. I could see it's the 9th fault of this drive, and it happened a minute ago, where it had an external trip. So that's kind of a cool little feature to it as well. But I will tell you this, and I'm winding down here. Most of these don't take a whole hour to complete. But in all situations, irrespective of the fault, in all situations, and this is part of the design and development team, the last thing we want is the same thing that you don't want, and that is for your customer to be without water. If we can give them water, it may not be at the flow they're used to, and it may not be at the pressure they're used to, but if we can at least give them water to flush toilets and things like that, that's what we're going to try to do. So in all situations, the drive's going to ramp the motor speed down. So if if things are heating up, it's going to ramp the speed of the motor down automatically to allow things to cool down a little bit. And if need be, it'll shut down But once it shuts down, it's going to come back on and recheck to see if that condition still exists. And that doesn't take very long for that to do that, and it'll do it, I think, 3 times. It'll come on. For example, if you got a dry well, well, it'll come on in an hour and see, did the well recover? Come on in another hour, did the well recover? Come on a third hour, did the well recover? If the well recovered, it goes right back on stream and everything's hunky-dory again. But after that third attempt, if it doesn't see that condition has changed at all, then it's going to go into what we call a hard fault, and that's when you'll get this display. What we call a hard fault there. When people come up to our factory, and we did this for the first couple of months of this year before COVID hit, we had factory tours and we spent a day training, and I hope that this fall we are able to do the same thing. But this is a great way to train you with these training drives. I used to run around the country with this big old drive over here. Tough to get through airports, and just very cumbersome. And I do a little drive training class, but I had these little things made up over here, which is essentially the programming of the drive itself. But it's I can ship dozens of these things out. So when we do a contractor meeting, everyone in the class can program drives with these little trainer drives. But it'll walk you through that quick start. If these are something you're interested in, let us or one of your Flint and Walling guys know. You can go and see what kind of parameters, settings, and adjustments, all the diagnostics and the protection and the fault log and the activity there is all part of that as well. We're running down up against the time limit here. Again, appreciate your attendance today. I've got a couple more I'm going to do this week, and then I've got a couple of I'm doing next week. So you can see what those topics are. If there's any topics here that you have some interest in, please feel free to register and come back. By the end of this week, I'm going to be posting up an entire June web conference schedule. And as long as this social distancing has kind of disrupted our way of life, this is a way we're able to reach out, at least communicate, and feel like we're, at least communicating. So check that website back out here in a few days to see the expanded schedule. And then also on that same page, just as an FYI, I get asked this a lot. If you've got somebody that wasn't able to sit in today, I am recording these, and as I record them, the marketing team will upload them to our website. So on the same page, it's got the schedule for web conferences. You'll also see an archive of some webinar recordings. So these are just some of the ones that are up there at the moment. So with that, folks, I'm going to shut this down. I appreciate your attendance today. And again, we're going to be back tomorrow and the next day, and then a couple times next week, and then we'll fire a bunch more out for June. If you're traveling, which most of us aren't, but please travel safe and stay safe. And until next time, this web conference has now come to an end. Thank you very much.